As we get ready for test 4.2, I wanted to take a look at a few of the ways that we can use Desmos to help us with the topics on this test now that we'll be in Aware and have access to a calculator. So these are some tricks or pointers that can help you check your work on this test and on the STAR EOC test at the end of the year for these topics. Our first topic on the test is simplifying radicals. So I have some sample problems over here on the right side and Desmos in testing mode over here on the left. And the way we can use it is to check our answers. The trick or the idea I'm going to be using in all of these is to set variable values. And I'm going to replace any variables used in the problems with like A, B, and C. So I'm going to set A as 3, B as 5, and C as 7, just so that I have some unique prime values for all of these letters. Then, whenever I'm looking at a problem, like number 7 here says square root of 80p cubed, I'm just going to replace p with a. So I can type it in as shown and put square root of 80 a to the third, and I get some kind of a number. Then I can put in the answer that I got, which would be like 4a square root of, what would be left, 5a. And if my answer is correct, then it's going to match. So we could use this kind of substitution trick in a lot of different sections of Algebra 1. But it's quite helpful here when we have a variable and a number part and we want to substitute something to see if it's the same. Looking at the second one, I could put square root of 147a cubed, so I'm going to use m as a, and then b cubed, I'm going to use b as n. Then my simplified version would be 7, say a squared, b square root of, that's 49 times 3, a, b. And you'll see that I came up with a different number because I purposefully got it wrong to see how it would look. So in this one I got 704, in this one I got 2,113. So as I'm typing it, I'm sure you saw the mistake I intentionally put in there was when I factored out a cubed, I should have only taken out a single a, not a squared. So if I correct my error, then immediately I have the correct answer, and I can validate that this is the right solution. I don't know, do they have any in here with coefficients? Yes. So we tend to mess up on ones with coefficients, with combining existing coefficients with any numbers coming out of the radical. So we'll do one more of these as our last one. So 6 square root of 75, and we're going to use all three of our variables, a, b squared, c cubed. Whoops, I forgot to go back to the baseline, c cubed. So that's our original version, and then I would factor out a 5 from that 25, so I'd have 30. I'd factor out no a's, a single b, a single c, and then left in the radical I would have 3ac. And we come up with the exact same number. So we know that this is properly simplified from this because they give the same value. So that's topic 1, and hopefully that shows you how substitution can help you check your answers for those. Our second topic is adding and subtracting polynomials. This one I honestly think is just not even that necessary because it's not that hard of a topic, but it can help you if you're worried about making like distribution errors or something like that. And we're basically going to use the same idea of substitution. So say number 7 has a subtraction, so I could type in exactly what I see here, again replacing letters, but this one happens to already be a, so that's nice. So I can do 5a plus 4 minus parentheses 5a plus 3 parentheses, and I get 1. Then my simplified version, let's say I do 5a minus 5a, I get 0, but then I do 4 plus 3. I mean, this is just too simple, but if I forget to distribute the negative, it might help me to see that. Maybe let's look at number 11 as one more of these, and then we'll move on, because this topic, I mean, you don't really need Desmos. It's going to take more time than it's worth to try to type this stuff in. So that is one consideration when you're using Desmos, is that it takes quite a bit of time. So if you are worried about finishing a test, then definitely don't waste a lot of time on this. Use it to check answers that you're not sure about once you've done everything, but like don't spend the whole test just typing stuff in Desmos. It's a bad idea. 2a to the 5th minus 14a to the 4th. So that's what we get for our original version of, this is number 11. So let's say afterwards I do 12a to the 5th, and then I have this minus 2a to the 5th, so I put 10a to the 5th, and then I have minus 14a to the 4th, so I'm going to put plus 14a to the 4th, and then I have minus 10a cubed, and then no a squareds, and I have negative 6a minus 10a is minus 16a. And I get a different number, so that's where I was saying it could help you to notice if you forget to distribute a negative or forget to distribute some kind of thing outside the parentheses. So in this case, I didn't distribute the negative to one of the terms, which would be the a to the 5th term. So I did 12a to the 5th minus 2a to the 5th, forgetting that the minus would get distributed. This should actually be 12 plus 2, which is 14, and then I have the correct answer. So that is adding and subtracting polynomials, but that is just collecting like terms, so hopefully we don't need Desmos for that. Multiplying polynomials is an interesting one because we have two approaches here. One, we can use the same substitution trick. So we'll start there and say I have 6, not n, so I'm doing number 15, 6a plus 3 times 6a, same variable, minus 4, and I get 294. And then if I put in my answer, 36a squared, and then I have 18 minus 24, so minus 6a, and then minus 12, I get the same 294, so I can be relatively sure that that's correct. If you want to be really, really sure, you can change a to be a couple different numbers, and if they keep matching, then you can be even more certain that it's correct. But you're already pretty certain at this point. The odds of it randomly being correct is very low. So another thing that we can do with multiplying, if these are single variable polynomials, we can actually, these represent like lines and quadratics and things that have a shape on a graph. So we can use the graphing calculator, and instead of using a, b, and c, let's look at number 15 again. I could say y equals, I don't even need the y equals, but just so we understand that we're graphing, 6x plus 3, parentheses, 6x minus 4. So this quadratic function that we end up with, this parabola shape, is really just a product of two lines, 6x plus 3 and 6x minus 4. So then if I were to write it in its like correct standard form for quadratics, then it would be the same thing I typed in before. So it would be 36x squared, and then we had minus 6x, and then we had minus 12. And as I finish typing it, the red graph, it exactly overlaps the black one. So if you're not sure, you can toggle it on and off and see that the black one's behind there. So by getting the exact same graph, I know that I've got the right expanded form, so the right function. It means the exact same thing. And that works really for any of these polynomials where you have a single variable. Just use x as the variable. So we'll look at one more on number 21. We can do, let's just erase all that, 7x squared, and then minus 6x minus 6, and then we're multiplying that by 2x minus 4. So this one, you can see, is a funny curvy shape called a cubic function. That doesn't matter. We don't care that it's a cubic function. All we care about is the answer that we type in going to perfectly overlap with it. And if we do it right, of course, it will. So here we would have 14x to the third, and then minus 6x squared minus 28x squared is minus 34x squared. And then we have plus 24x, and minus 12x is plus 12x. And then we have plus 24. So I've typed in something incorrect because this blue graph is a bit different than this black graph. So that means that I either didn't distribute something correctly or made an error in collecting my like terms. But either way, by typing in the original and my answer, I can see really quickly that there's some kind of error there because the graphs are different. So similar to the substitution trick, but I like this one because we get to see the actual shape of these graphs. So let's go find the error. We had 7x squared times that is 14x cubed. 7x squared times that is minus 28x squared, and another minus 12x squared. So 28 and 12 should have been minus 40x squared, and now the graph is magically perfect. It fits exactly over the black one, and I know 100,000,000% this is the correct answer to the problem. So that's great. Similar for dividing, although dividing gets a little weird because dividing polynomials makes for some really strange looking stuff on graphs, but we can still use this same idea. Again, you can use the substitution method where you put in A, B, or C for the letter and then see what you get, or you can use graphing as long as there's a single variable. This one is a little different as far as graphing because of remainders, but that applies whether you're typing in your answer or a graph. It doesn't really make a difference. So for my first one, I'm going to make a division and put on top x, I'm doing number 1 here, x squared minus 7x minus 11. And then on bottom, we have x minus 8. I don't need those parentheses. I'm just typing it so that it matches exactly what's on the paper. And we can feel comfortable that I've typed it in that way. I don't even have to type it as a stacked fraction if I want it to match exactly what was typed there. I could, with the parentheses, put a division symbol. Actually, I don't know if Desmos can do division symbols, but whatever, you get the idea. So, funny graph, right? Like, weird thing going on here. And if I put in my answer, which, of course, I should have calculated beforehand, that's going to be x plus 1. And then that's kind of interesting. That x plus 1 looks like it goes right between those green ones. Then we need to have a remainder. So the remainder in this problem would be a -3. So we would do minus, and then like we write it on paper, 3 over x minus 8. And as soon as I finish typing the quotient, including the remainder, the purple graph perfectly overlaps the green one again. So yeah, this is a way to check division answers. Just remember that the remainder gets typed in the way we write it on paper, and you can check your answer for division as well. We'll do one more of these since we did 2 of the others, and then that'll wrap it up. Let's pick one that looks intimidating, I say, as I realize I have to do this in my... Oh, there's an answer key. Now I can pick whatever one I want. Great. So number 14... 18 looks kind of interesting. It's written in a strange format. Let's do that. So we have negative 5k or 5x squared plus x cubed. Ooh, not even in standard form. Great. That's a really ugly one. But Desmos doesn't care if we type in standard form. It just cares that we have a y equals something. So when I hit divided, it does make it stacked. I can't write it exactly like on the paper, but it's basically, you can tell it's equivalent. Okay. Let's see. Oh, I put k. Of course, that's not going to work. Can I get there? X. Great. Okay. Funny graph. Weird thing. Doesn't matter. We're going to put in the answer, which I conveniently saw there's an answer key down here. And number 18 says the correct answer is x squared minus 4x plus 4, and then because it's such a funny graph, of course it's going to have a remainder, plus 8 divided by -1 plus k. Why we don't put k minus 1, I don't know. Okay, so that is now x. I keep forgetting. X. So now my red graph is perfectly overlapping my black graph, so this is absolutely the correct answer. I did cheat a little by using the answer key, but this is a way to check your answers when you're taking a test or working on the STAR test.